here we are talking about GraphQL caching. What is GraphQL caching? We'll see it in a second, okay? By the way, you can see here, you see I'm going to walk around because I don't have my fancy setup. So this is my Twitter handle, so you can follow me there if you want to. Couple of bits about myself. They introduced me already, but if you want to hear more about me from me, you can just go and subscribe to my newsletter, node.js. Yep, going to talk about Node stuff, a lot of Node stuff today. So we'll see if you like it or not. Maybe you do. So I just wanted to start say that I'm a kid of the 80s, and I don't know many of you were around, but there was this nice show being streamed on television where David Copperfield was being thought in half. And I got really fascinated about, demystifying and learning about magic tricks, how they were done. How was he doing that? Come on, okay? And, all things about magic is that you want to, it's actually a lot of hard work behind the scene, and you just see the results. So you might wonder, why are we talking about magic in a JavaScript presentation about GraphQL caching? Okay, so what I'm going to show you today is how to make your GraphQL gateway be 4 times faster, or maybe more, okay? So we are making things go a lot faster. So, ouch. Talking about this, tool of the crafts. What are we going to use now today to do this? So first one, it's we are going to use Fastify. What is Fastify? It's a web framework for Node.js that I have built. Now, you can't read this because I can't. So hopefully you can, but I can't. Okay, so this bar is Node Core, you can see. So this bar is Fastify, and this bar is Node Core. This bar is Express. Okay, it's fast. And this is the number for requests per second. So it's very similar to all the things that you've used, but it's significantly faster and built for the latest time of Node.js, not something that is falling behind. Thanks to Beth that mentioned it earlier at the beginning of this talk, at the beginning of this day. So it has a nice logo. I don't know. That's the only reason why you should use something, right? Just use a technology that has a nice logo. We have stickers downstairs at our booth. So if you want the NearForm, go to the NearForm booth. There's Fastify stickers around, so you can take them. Other tools that we're going to use today is a library called Mercurius. You'll see that this logo is significantly nicer than the previous one. I'm sorry. And it's a GraphQL adapter for Fastify. So you want to stick GraphQL on top of Fastify, you can just use Mercurius. What's its speciality is this little option here. One of them is this little option here, just in time. What does this mean? It means that it uses just-in-time compilation of your GraphQL queries. So basically, it turns your GraphQL queries in JavaScript code, and it's actually run that code. So this means that it's actually significantly faster than almost anything else you can use in Node.js, at least that you by default. So somebody that's not using the same techniques. Going to use this other library called AutoCannon. It's a nice load testing written in JavaScript. So we'll see that in a second. So, okay, this is experiment. This is magic, okay? So what we're going to do today is that we have a bunch of, this is a little bit the gateway setup. So we have a GraphQL gateway that is configured to connect to 2 services. One a user service and the other one is a post service. Okay, I can't jump there. I had a nice pointer setup that I could just highlight things, but I can't, I'm sorry. And we have a user and a post. And we are enabling the just-in-time compilation. We could turn on and off our caching system. Okay, this is the magic. We'll see. So one of the services is very simple and trivial. It just serves from memory. So nothing really fancy going on there. So okay, we have learned the tool of craft and the time for some magic. So before doing any benchmarking and anything that is actually any performance work, you need to establish what we call a baseline. How does my system run before learning any load? So first one up is the latencies at the 99th percentile. That's what you need to measure when you're doing anything, any performance-related work in the HTTP scenarios, which is pretty good to start with, but it's 80 milliseconds. And by default, without doing any optimization, this system can do around 3,000 requests per second. And some good throughput. Okay, it's fast, but can we make it faster? That's the question. So in order to make it faster, what we can do is to use a tool that we have built called Clinic, which is called Clinic Flame. Anyway, you can find it online, clinicjs.org. And you can do that and generate this nice report, which tells you, more or less, where we are spending a lot of time. So if I'm walking down here, you will see this big block. It's in pink, so you can probably see it, that I've circled it. And this block, it just represents the HTTP requests that are going out. Why do we find it? Because it's using a library called Undici. What is Undici? Is the fastest HTTP client for Node.js that you should be using today. So if you're using Axios, stop using Axios and start using Undici. You will be not disappointed. I'm absolutely certain. Anyway, it's using that. So we are spending a lot of time doing HTTP requests. Why? Well, the full point of GraphQL Federation is to do HTTP requests, right? So maybe it's what is happening. So, okay. How can we improve this? And, well, let me show. If I turn on the caching, I can just cut latency by 4 and multiply by 4 the number of requests per second. Literally, just turn it on. And by the way, I'm not caching anything. I'm just literally turning it on. 0-second caching completely. Just, turning it on will magically make your thing 4 times faster without you absolutely doing nothing. Good. Seems a good thing for one day, right? That should just go away. That's it. Nope. Can do better, actually. We can turn on caching, and it just improves a little bit. So let's do a little bit of a check. Now, if I'm doing my flame graph, I can see that now that the HTTP block is gone. So we are not doing HTTP calls anymore. So my caching seems to be working because all of this is now caching. So I'm spending all my time, instead of doing HTTP calls, caching stuff, which is probably better and faster than doing HTTP calls. Okay, but where did the HTTP calls go? They disappeared, right? I cut somebody off, and how? Well, the solution is by deduplicating things. So I don't know how many of you like clones. They didn't like clones so much in Star Wars. So, there's a clone there. And we can deduplicate and remove some clones. Okay, so here we go. How? Well, how many of you know the Node.js event loop? Probably all of you. Maybe if you don't, I'm going through it in a second. So you have your JavaScript running. When your JavaScript is running, it's scheduling some I/O activity. It can go into the kernel async I/O block, or it can just go into the thread pool. Then when they are done, they will get back into the event queue and go into the, and then they're being processed by your JavaScript again. One at a time, roughly, okay? Now, you're probably not so familiar with this diagram. Funnily enough, the previous diagram and this diagram is essentially representing the same thing, this with a little bit more detail. So, okay, you have your event loop running. We are waiting for some event to happen. After some events happen, it's going to call up in C++, and then C++ called JavaScript, which, when it finishes, it probably schedules some promises. You're all using promises today, right? If this is there still somebody that is still anti-promise, anti-async await? No? Okay, you're all gone. Okay, there's only me left. No, I'm joking. Okay, and it's scheduling some stuff in the microtask queue, some promises, and after all of those are processed, it's actually going back to the event loop, waiting for the next event and to start this thing all over again. Okay, so how does it work? Okay, let's see that when you're calling a function, okay, calling a JavaScript function, we can actually create a key for that specific function, okay, and all done on the promise it returns. So it's an async function that we can just, generate a key for those arguments and then keep the promise. When somebody else, is called that function again, we could actually check that we have the same promise, that we have an execution of that function with the same key. Sure, here is one. And if there is one, we could actually, return them the pending promise and not execute the function all over again. Oh, so this means it's we have actually, creating what we call a dedupe cache, which means that we can actually dedupe the execution. So we can just literally avoid some unneeded computation in my code. All of these, you don't have to worry. It's actually very dangerous to do that stuff. So don't do that at home. You don't want to try to, cut people enough at home. That does not end well. Same thing, don't cache promises at home. But if you really want to do them, and this is actually perfectly safe to do, you can use this module called async cache dedupe. This is a little bit of a utility that I wrote and prepared that actually just does that in a very, very efficient way. So you can just download it from NPM, and that's it. Okay, so I'm using this utility in my GraphQL caching system. Right. We still have a problem. We need a cache key. The whole premise of this was we need a cache key. So now we don't have a cache key. How can we get a cache key from a GraphQL resolver? Well, look, in a resolver, we have a few bits and bobs. We have a nice parameters. We have the object, the arguments, the context, and the info, which are listed over here, what they are. I don't want to go through too much. You're probably familiar with them anyway. So we can take all of those and actually calculate a JSON from those. However, a JSON is not enough. We need a stable JSON. What is a stable JSON? It's a JSON that has the properties always the same order. Therefore, I can create two objects that has the properties in different order will generate the same JSON. So I've actually computed a key, which solves all my problem. It's still a main bottleneck doing this operation, but still we have improved stuff. So basically, the key requires for GraphQL require a little bit more work because we have a lot of fields, we have a lot of things to consider. Anyway, that's the gist of it, and I'm probably running out of time. So just deduping gives us 4 times the performance. Okay, just deduping thing. I'm not caching anything. I'm just removing the execution of stuff that I'm already doing. So what does this mean in practice? It means that if I'm accessing a database, I'm not accessing that database anymore. Because if I'm already reading from that database, I can just skip it. Okay, so, and this is another number. Yeah. All of this is just theoretical, right? You'll never want to put an in-process cache in production. Because why? You run up in, they go very quickly out of sync. I'm doing a cache on a system and not a cache on the other one. So the two things can return different results, right? And they tend to leak memory, and typically it's the only thing that they work with is very low time to live. So the solution is to throw data into Redis. Do you like Redis? Okay, great. You're learning something today. So throwing something to Redis just doesn't work. Very simple. And I'm going to show you the math why most of the time when you're putting stuff in Redis is not working for you. So let's say that you have 100 GraphQL queries per second. Okay, and each one of them has 20 resolvers. Now, with 20 resolvers, it means that in order to access Redis and check those values, we need to do 2,000 gets per second. How much time it takes to do a get, a Redis get on AWS? Let's say that you're talking from an ECS server to AWS. It's taking 15 milliseconds. Well, 15 milliseconds is not a lot of time, right? It's 7 milliseconds to go, 7 milliseconds to go back. You can't really measure that, right? Try. However, if we want to do 2,000, we need to do 0.5 millisecond. And now we are in trouble. Because how can we make a Redis request in half a millisecond? It's not fast enough, okay? So it's not going to work. Well, I already solved that problem. Okay, so it's another talk. So I did another talk at JsConf talking about exactly this problem. So it's very simple to solve this problem. And you just need to enable a flag on IO Redis. So if you're just using an IO Redis, you can just enable a flag and we'll just fix it for you. How does it work? It's called Autopipelining. And it's a technique to automatically batch a bunch of Redis commands together. So let's say that in a given event loop tick, we want to perform a 2,000 Redis get, or 100, whatever, okay? All of those will be batched into a single Redis pipeline. What is a Redis pipeline? Is a single command that we send to Redis at the same time, in a single time. And after it comes back, while that's executing, we can actually accumulate more commands, and then we send the next one. Therefore, we can only pay for that 15 millisecond of round-trip time between the Redis and my server once for 1,000 commands. This maximizes the use of Redis, truly. But you can actually scale it pretty deeply. And Redis usually can execute a lot of commands, really. So don't worry about it. Okay. Does this sound familiar with the technique I talked about before about the event loop? It's pretty much the same thing, right? It's all turtles all the way down, as they say. Okay. This is another good citation. And if you hope you get it. If not, come to the booth, I will explain, whatever. So let's going a little bit more. So what is in real life? We deploy this in real life, in a real world project, not a dummy one, okay, that you can very quickly execute. It's gone. Oh, okay. It's on a real project, this went 100 more time requests per second, easy on the same hardware. And it did a 15x expansion factor in Redis, which means a lot of Redis commands getting executed at any given time. So this was a few thousands concurrent and a few thousands whatever. Yeah, oh, it's beeping, good. So okay, well, I've been going through this cycle, so there is a problem, right? So there are two hard things in computer science, and according to Rob Pike. One, it's naming things. Okay, I have a lot of fantasy when naming my projects, so that's typically done. The other one is caching validations. Hey, happy days. So we are talking about caching. I should mention caching validations. So how can we implement caching validations? And yeah, we have caching validations. Easy, no big problem, done for you. So how do you do it? We do a thing called tagged caching validation. So whenever you want to put something in the cache, you can add some tags to the data return to your resolvers. And it can be generic, or it can actually be very specific to your actual arguments. Whenever you want to invalidate them, typically after a mutation, you can just specify this policy, and you just specify invalidate, and just return the tags that you want to invalidate. And that's it. And we automatically this solution does automatically do it for you. This creates some load on Redis. So we also have a nice companion Redis garbage collection script that you can run from time to time to shrink it a little bit. It's stable, it's not leaking memory on Redis, but it will take a little bit more time if left unattended. So you might want to, every hour or so, do a little bit of a clean so that there is nothing, no leftover data. So yeah, that's it really. So I hope I am in time. I didn't go over time. I just thank you for having me here, folks. As usual, you can follow me on Twitter at Matteo Collina or drop me emails for any question whatsoever. I tend to reply questions on Twitter pretty quickly, so just shout them at Twitter. I haven't done that video thing. I'm so sorry, Harris. I'm so sorry about that. I haven't done the video link. So if you are watching online on the live stream, you can ping me on Twitter, or you can just meet me at the booth downstairs. If you are in person, I'm going over there right now. So yeah, and yep, a couple of words about NearForm. We are a professional services company based in Ireland, and we are hiring, as everybody, but we are hiring. We are in 29 countries now, so whatever country are you, we can probably hire you now. So if you, even the UK, of course. So, you know, it's if you need any help with JavaScript, Node.js, GraphQL, React, whatever, we are here to help. Just wanted to say thank you, guys, and yeah, bye.